We're in the year 2072, right, at the Bureau of Energy Research and Legacy Information Networks, in short, Berlin. Doc, are you there? Right over here, Dennis. Why is it so dark? Seems like the T1 needs a bit of fine-tuning. Give me a moment. What is that, Doc? Oh, Dennis, that's just my newest invention, the KI bully. It looks crazy, Doc. What does it do? Well, it will help us explore the technological state of past decades. Is it a time machine? Much better, Dennis. It is an AI time machine, and it is ready just in time for my newest research. Get in, and don't forget to put on your seatbelt. We're going to the past. They're getting in. Obligatory flashes, and they're gone. All right, so let me introduce to you our characters, right? There's Doc Wolfgang Thüringer, who is a researcher at the Berlin, and he's specialized in history of technology and sorcery, and he likes coffee. Then there's Dennis Müller, who's the working student at Berlin. He specializes in asking the right questions, and he likes black tea. And then there's me, Johannes. I'm a senior data scientist at Celebrate. And yeah, I specialize in bringing AI to the real world in my jobs and also creating stories and go to conferences and present them. I'm also a Hugging Face fellow. That's why I'm wearing my Hugging Face shirt today, right? So yeah, you can ask me afterwards. I've got a lot of slides if you want to know more about the fellows or anything of my work. And I like Club Mate, actually. I'm a bit sad it's not here at the conference. That's for the organizers. Next time, please, some Club Mate would be fine. But yes, for the rest of the talk, I'll be Doc, right? I'm basically in the role of Doc now. I put on my glasses to look more Doc-like, more competent. And you are Dennis, like every one of you, right? You're Dennis, you're Dennis. All of you are Dennis, okay? Then let's go. Wow, Dennis, it worked. We are in the year 2025. Look at this. There we are. Totally not pasted in. All right, let's get to work. I brought my Paradigma Analyse System Terminal, which can really well be one word. In short, you can also say past, right? Let's boot it up and let's get going. The great thing about it is it can sync to any time we are in. So enabling time sync. And we're just waiting a few moments for the immersive experience of the slow internet of the time, right? So just like. Yes, connected. It worked, Dennis. Great, now we just have to set it to research WebAI in this time, and then we will see. Yes. Oh God, Dennis. Great, Otto. The records were correct. I can't believe it. The people in this time really seem to use API calls to talk to their AI systems. Can you believe it? And not just a few. Look at these numbers. It's crazy, Dennis. That's some research and a prediction of the market size for API calls related to AI. In 2024, it was already really big. It was around $49 billion and was predicted to grow to $750 billion by 2034. That's insane, Dennis. Why are they doing that? And look at these numbers from a survey from 2023 to 2024. These companies grew their numbers, their API call numbers, by this amount. Insane amounts, Dennis. Can you believe it? And then there is this really way too small and ugly chart, but look at it. It's actually from the same survey, and it shows the API tool usage of the people who took the survey. And you might see it's not adding up to 100%. So probably they are even using multiple systems at once. And look at the names. OpenAI, Microsoft, Google, AWS, Meta. Damn, those old companies. I can't even remember them. But look at them here. They're really like the rulers of the API at this time. And the people are just giving them their data for free. Can you believe that? Why are they doing that? Okay, maybe let's have a look, Dennis. What really makes sense? Why would they use APIs, right? I've got some ideas, right? And it's something like, it can do heavy lifting in this time. You know, when they used to use really big models, I remember, it's like, yeah, gigantic models that could do, well, pretty well for their time. And, well, the APIs, or like the cloud infrastructure, helped them to quickly scale, actually. So that's great. And it was easily updatable. But, of course, there are problems, and people knew about the problems, right? Here's another chart, which is way too small again. It shows that, yeah, people had problems, a lot of them, actually. And stuff like validating security or evaluating the LLMs, it's just basic stuff, you know, you should really care about. And there are even more problems, I would say, right? Like the data, as I said, it's not in your hands, Dennis. Just imagine getting your data, sending it to some cloud service, and then you just hope that they are not using your data. And they say, okay, we're not using it. While at the same time saying, oh, you know, if we can't train on copyrighted data, that's not fair, then we're losing the AI race. And I don't know. I don't trust these people, Dennis. Also, the speed of the API calls is really dependent on the connection, right? And you've got no model control. You're not in control which model they give you, right? I mean, of course, they probably have some models that you can choose from, but if they choose to deprecate, they just deprecate, and it's gone. It's crazy. So what's a solution, Dennis? Did you say WebAI? Ah, maybe. Let's have a look. WebAI. So what's WebAI? Well, let's look what they are doing here, right? Usually they have a browser and like a chat window, and then they send some request to the cloud with their neural network, and then they get it back. That's their API calling stuff. But as I said, I don't like it, right? I really don't like it. So what if we cut out the cloud and put our model into the browser, actually, right? Like really into the browser. The benefits we get from that are privacy. We don't have to send our data to the cloud anymore. Zero latency, or well, let's say close to zero, right? There's at least no connection latency. Probably there is some latency in inference speed, like the time that your answer needs to produce. And there's also reduced cost. People don't need to spend money on infrastructure anymore. And of course, it's offline capable. Well, after you first downloaded the model, right? You download the model, and then you can use it on your device. Talking about on-device, there's also on-device AI. So you might wonder what's the difference, right? Well, I would say the main difference here is really, Dennis, that on-device AI really is specific to the underlying hardware, while the web AI is basically one code base that can be distributed to a lot of devices, right? You don't need to care about different code bases for different devices. You just have your one browser code base, and that should work for everything. But how does that work, you wonder? Well, in 2025, there were some technologies that would enable that, right? Basically, the engine room of everything, the lower decks. And there are these things as WebAssembly, ONNX, WebGL, WebGPU, and Web Neural Network. Let's talk about them, right? So let's assume, Dennis, you want to create a website. Let's say you like it in 2025, and you say, oh, it's great, I want to stay, but I don't have any money for this time. I don't have a bank account. So you decide to sell our nice KI bully for around 100,000 euros. which is a bargain, right? And yeah, what do you need to do? You want to set up a website. So you need some laptop and probably some JavaScript in this time. And then you hack together your code, and yeah, that should be enough to sell a KI bully, right? But then people come and say, oh, I don't know, I've never seen that. I don't know if I want to spend 100,000 euros on that. So you say, no problem, it's AI powered. People are more like, yeah, okay, cool, yeah, let's make this worth more, okay. But I'm not completely sure yet. So you say, okay, no problem, I create a live AI demo on the website. So you can see what the KI bully can see, for example, when it drives around, right? We add some face or some object detection. Just upload a video of whatever, and I will show it to you with the eyes of the KI bully. So you writing some more JavaScript code, and you're trying it, and you figure out, okay, it's loading. And it's loading, and it's loading longer. It will take forever to infer even simpler models just with JavaScript code. So more or less the solution is using a different language. For example, like Dennis, in our time, Python is like the fastest language ever, right? Well, in this old time, maybe it's not the fastest, but it's quite okay. So let's say we want to use Python in the browser. There are some frameworks to do that, but what's even better is using WebAssembly. WebAssembly is basically compiling your Python code so it runs in JavaScript, and it is almost as fast as if you would run it outside of the browser in your native environment. So that's amazing, and there are even more languages that can do that with WebAssembly, right? If you're a big Rust fan, which is reasonably fast, or if you're old school C++ or Java fan, no worries. You can run that with WebAssembly. Amazing, right? But of course there is more. There's WebGL. WebGL is kind of ancient already in 2025. There are two versions of it. So version 1 was in 2011, version 2 in 2017. What can you do with WebGL? Well, you can build nice 3D models like this KI bully right here in the browser, right? What do you need it for? Well, maybe you need some games or whatever you like, Dennis, And it works by communicating between the CPU and the GPU. So for example, the CPU will tell the GPU, set this color, or find this texture, or draw a triangle. Now, the problem is, with WebGL, it's slow. It's mostly just single-threaded, even though it got a bit faster in version 2, but it's slow as hell, Dennis. Even for this time, it's slow. So people came up with something smarter they call WebGPU. And this one is multi-threaded. So it can do a lot of operations at once. It can communicate way better between CPU and GPU, because the GPUs in 2025 were already pretty powerful. So basically, when you compare WebGL and WebGPU, WebGL is still pretty good for, as I said, stuff like games in 2025. But WebGPU is the one that's really doing the heavy lifting, like creating neural networks, or like running neural networks and doing hard math problems on your browser. Also, WebGPU is like a way thinner wrapper around existing software like CUDA or Metal or Vulkan. So yeah, it really helps. People of the time also came up with a really strange name for it, which is called GPU, and it's general purpose GPU compute. I don't know where the C for compute is left, but yeah, GPU. If you want to sound smart, Dennis, somewhere on a dinner party, you can drop it. And then there's Web Neural Network, which is still a pretty new thing in 2025. And, well, I've got this monster of a diagram here. Dennis. It's not that easy to describe. But you should think, let me go over here. It sits here, right in the middle, and it should show that it's basically on the same level as WebGPU and WebAssembly. Just what really is different is that it can also cater to more modern things like NPUs, which are the neural processing units, which manufacturers began to add to their devices in the 2020s because everyone wanted to have AI in their devices, right? So yeah, that's where WebNN shines. It should be like, yeah, die eierlegende Wollmilchsau, Dennis, you know? So it's just for everything. It didn't work out that well, but people don't know yet. So yeah, if you want to try it out, and if you want to find out if it works on your browser, you can go to a website here, but we don't do it now. So in summary, you know, if you use JavaScript and CPU, you're okay fast. If you use some other language and WebAssembly and the CPU, you're getting faster. And if you use JavaScript, WebGPU, and your GPU, you're pretty fast already. If you use web neural network, you might be fast, but it really depends on your system. All right, let's get to ONNX, Dennis. And let's imagine you are running a kebab shop, right? And you've got like the best vegan kebab in all of Berlin, which is hard. There's pretty good concurrence. And then there are other shops that want to buy the kebab from you. So you say, okay, I can distribute it, but you can't just give them the kebab and say like, okay, you do it now, right? It's not like they can reverse engineer your kebab. It might look similar, but it probably doesn't taste similar. So you give them the recipe, right? And that's how you share your kebab, basically, by the recipe. And with neural network models at the day, it was pretty similar, right? So someone might train a PyTorch model, and then there are other companies who only run TensorFlow because they're a bit old school, or JAX because they are kind of old school but look fancy. And they're like, oh, great, that's a great model, we want to have it, but you can't give it to them because they're only using their frameworks, right? And they don't want to switch to PyTorch for some reason. So that doesn't work. So instead, what you all agree on, for some reason, is a fourth framework that's called ONNX. And with ONNX, now you can all run the model you created. It won't taste exactly the same, speaking in kebab words things, but it's pretty close to what you created, right? So that's ONNX. Let's move to the upper decks, right? Some frameworks. And I have to speed up a bit because there are many slides left and not much time left. There are some great frameworks already in the time, mainly TensorFlow.js, Transformers.js, and Web LLM. So TensorFlow.js is basically the old TensorFlow with some JavaScript. And yeah, it's created by Google, of course, and maintained by Google. It's okay-ish maintained by Google, not very great. But yeah, what you can do with TensorFlow.js is, for example, train your model in JavaScript. Why would you want to do that, I hear you ask, Dennis? I don't know. But maybe there are people who really like JavaScript and want to train their model in JavaScript. And then they can do that with TensorFlow.js. But you can also just get pre-trained models, for example, from the TensorFlow Hub or the really unknown TensorFlow Model Garden, or you just have it trained in TensorFlow on your regular Python script and then convert it to TensorFlow.js, or you have it in Keras and you convert it to TensorFlow.js. The main problem is there are not that many people using TensorFlow anymore. Yeah, but yes. Basically, the backends of TensorFlow.js are most of what you've seen before. So there's CPU, just real simple CPU, there's WebAssembly, WebGL, and WebGPU. But not all models run on all backends. You can check it in this link down there. And yeah, then there's Transformers.js, which is created by Joshua, aka Xenova. And you can follow him on his Hugging Face profile or GitHub. And then he always posts a lot of stuff about new models, stuff he created. Basically, Transformers.js is great because you can go from the Hugging Face Hub, take one of the models that are compatible, which are over 2,100 models at the moment, and load it with Transformers.js in your browser. So Transformers.js is leveraging JavaScript and the ONNX runtime, which is a really powerful thing. The ONNX runtime supports basically everything that's there, right? You can use WebGPU, web neural networks, and WebAssembly. And that's great. And then there are a lot of demos in this profile. The WebML community on Hugging Face is dozens of newest models that are run on your device your WebGPU. Okay, and then there's Web LLM, just really short. It's a new project. It's really focused on just running LLMs in your browser, and it's using the LMC project, which is a compiler specifically designed to run stuff on your device. So let's have a look at the real world, what works and what doesn't work, right? So WebAssembly, for example, works in most browsers that you might use. A WebGPU, a bit difficult. Firefox has nightly support for it. Safari also like tech preview. Web neural networks, even more complicated, usually just running on Windows. And for WebGPU, it's even a bit more complicated than I showed, because that's the reality of WebGPU, which kind of makes it hard, Dennis, right? In this time, you know, if you're on Linux, you need to find your flags, and yeah, you need to somehow run that. If you're on Windows, you're pretty okay. On Mac, well, you shouldn't be a Firefox user. Yes, and as I said, Safari, well, on the iOS and Mac systems. Yeah, it might work, it might not work. Just try it. All right, but what works, for example, is MediaPipe. MediaPipe is a small solution by Google. You can check it out. Then there's ML5, which is discontinued, but also some cool projects. They do kind of this stuff, body pose, hand pose, face mesh, whatever. And Photoshop Web, you might have tried it or not, is powered by TensorFlow.js in some things. Now that they use Firefly, I think they're using different systems. But yeah, TensorFlow.js was doing a lot for that. And RoboFlow, you might also know them. You can basically fine-tune models on your data with RoboFlow, and they just support 3 models at the moment, but you can also use the Inference.js, which is also powered by TensorFlow.js. And then there's Firefox AI Runtime, which is powered by Transformers.js. Yeah, there's some examples, Dennis. There are probably more in this time. But there are a lot of challenges, of course, like intellectual property, with 2L, but yes, because like when people give you their model and you run it on your system, of course you download it, and then, well, it's their intellectual property, they need to kind of encrypt it. There probably are some solutions. And there's, of course, the model size, hardware variety, and cold starts as challenges. Okay, Dennis, that's it. Quickly, we need to get back. Oh no! That is. What's happening? The path is crashing. What can we do? Oh God, Dennis. We need to get back quickly. But I always forget how to set the Schmidhuber Besserwisser-Matrix and the Einsteinsche Relativitätsumkehrer. Well, luckily I'm old-fashioned sometimes, and I actually let my AI write a whole manual and printed it out. So, yes, I know, amazing, right? But I don't read manuals. Nobody reads manuals, not even in 2025. So let's build an AI and just, you know, there's this thing they call RAG in 2025, and it's really fancy. Maybe we can build that completely in the browser. Luckily, I brought my emergency laptop. And there's another thing they're really crazy about in 2025. It's called wipe coding. So let's wipe code our RAG in the browser. Let's go. In and out, 20-minute adventure. Okay, we managed somehow, and people can try it out when they look at the slides later. But yes, great. Well, it's not really working that great, so we read the manual, and then we get back in. All right, we're going back, Dennis. So, yes, you see, in 2025, WebAI is still in its early phase. You know, there are a lot of difficulties, especially around hardware and compatibility. But it's worth trying it out, especially for simple use cases, you know. And there's no reason why you shouldn't try it for stuff like face detection, embeddings, or even smaller LLMs, right? Everything is set to get started. So yeah, thank you. And yeah, you can also follow me on LinkedIn if you want.
Thank you so much for the talk. Unfortunately, there are no questions yet on the videos platform. Are there any questions in the room, or feel free to post any questions there?
I have a question. What type of model sizes do you actually tend to use in such applications that are supposed to be deployed on web?
Yeah, that's a good question. The model size, I prefer models that are not bigger than 100 megabytes actually, because that's usually the size that I would, as a consumer, tend to wait for download, you know? And as of my experience, like when I create demos and I wait for downloading everything, when it gets bigger, oh, it gets harder. I mean, in the end, the stuff is saved in the cache, so once you've downloaded, it should be faster, but you know, sometimes you clear your cache because something is not working, and then you need to download it again. So yeah, the model size, I think that's really one of the things, like, yeah, that's really constraining it at the moment, because like the really good models are just not that small yet. So that's why I wouldn't use LLMs in the browser in production yet, and just, yeah, as I said, stuff like face detection where you can get really small models, for example, and yeah.
Is there any model family, though, that you have tested that worked in such environments?
Any model family? Well, models that are a bit bigger and work fairly well are the small LM models from Hugging Face, right? And also small VLM, actually, which is even still a bit bigger, but works when your GPU is strong enough. So I've got like an RTX 4070, which is a pretty strong GPU for a laptop, and it works, but it's something that you wouldn't assume works on like any phone, right? So, yeah.
So what is the coolest application you've seen that uses a model in the browser?
The coolest is probably one by Joshua that is conversational AI, actually. Let me, oh no, I don't show it. It's in the demos that I linked, like this WebML community stuff. There are a lot of great demos, and one of them is conversational AI, where you can really just talk to like your AI assistant in the browser, and it like, yeah, creates everything and talks back to you. That's pretty cool. And also the VLM stuff, where you can just like turn on your webcam and in real life prompt it basically to say like, what do you see? And you can ask it in real time. That's pretty advanced, I would say.
Another question, how are pre-processing steps packaged in ONNX? Do I have to rewrite my whole pre- and post-processing code around models?
Whole pre- and post-processing code around... I'm not sure if I completely get the question, but yeah.
It's like the whole pre-processing you need to do.
Yeah, I mean the pre-processing, I mean the output and input of the model should still be the same as without ONNX, right? So I would say like you don't have to completely rewrite everything. ONNX is really just like the format. Yeah, as I said, of course it might have a slightly different output in the end because it's like a different model a bit. Like when you talk about LLMs or generative AI, it changes a bit. When you're more deterministic in your models, it shouldn't be much of a difference.
Another just short question.
Thanks for the interesting presentation. I was wondering if you're a SaaS provider and you're aiming to make your model available, let's say lightweight model available to your user and ship it to the browser, if this is possible and if there would be an intellectual property preserving for you as a SaaS provider by doing so. So what's your view on that? So
you worry about the intellectual property thing, like so when you have a model and you say, okay, I want to give it out, but I don't want to reveal all my secrets, basically. Yeah. You come up with some business plan, some kind of charging them, right? Yeah. So I think the most advanced thing is encrypting, which I think is already possible with ONNX models as well, where you can encrypt your model basically, so not everyone can just look into it and figure out how it works. But it's one of the challenges, as mentioned, right? One of the challenges that are still up for debate, and where probably, yeah, providers have to figure out what works. I don't have a definite answer to that. But yeah, encryption is one thing I would first look into.
Unfortunately, time for questions is up, so feel free to approach Johannes if you have further questions and give him another warm applause. Thank you.